All right, hello. This is the Hazen and Sawyer case study for Group 5. My name is Nicholas. We have Hannah and Justin. So first, we are going to be going over the introduction. The objectives of this is to develop the best wastewater treatment system for a single household. We are going to be choosing from three alternatives, the best option. And we also have to adhere to the three pillars of sustainability in the decision-making process. That includes environmental, economic, and social and technical. The test parameters using C Wastewater Decision Support Tool.
Displayed below shows our input data that we are going to use for our C wastewater tool. All are a single-use household in Florida, but they do have some differences in effluent quality, energy usage, infrastructure, as well as costs and social and other technical factors, such as maintenance time, employee training, and some system intrusiveness. Alternative one consists of wastewater being transferred to a primary concrete septic tank. A recirculation tank then takes the stored wastewater and mixes it with cleaner effluent water. A stage one unsaturated biofilter performs nitrification of mixed wastewater and effluent water. Nitrogen pump goes back into the pump tank, which then transfers back to the recirculation tank. A stage two saturated biofilter performs denitrification on the water. Water is then transferred to the STU subsurface dispersal unit that releases water into the soil. For alternative two, wastewater is taken from the home and put into a septic tank where primary treatment takes place. Like alternative one, nitrification is performed on the wastewater from the septic tank, but a stage one unsaturated biofilter is used. The pump tank recycles nitrogen back into the stage one biofilter and transfers wastewater to the stage two saturated biofilter. Denitrification occurs in the stage two biofilter. After denitrification, wastewater flows into the STU subsurface dispersal unit, where water is again released into the soil, similarly to alternative one. With alternative three, wastewater travels from the home to a concrete septic tank for primary treatment. It is then transferred to an STE dose tank, which pumps wastewater into an STE drip zone. This contains a stage one and 2A lined biofilter. Wastewater is then collected in stage 2B saturated biofilter for denitrification. Wastewater is then pumped to a drip zone for effluent irrigation.
So the methodology of this system is to develop a viable wastewater system involving a septic tank, series of biofilters, and a dispersal system. The functional unit is going to be 1 cubic meter of wastewater treated, and we are going to be using the C Wastewater Decision Tool to determine the best alternative. We are looking at the inputs, life stages, and outputs as shown in the picture below. When looking at the metrics, we can ensure that the best alternative can be considered. So we're going to be looking at the environmental, economical, and social and technical, as said before.
On this slide, we have the C wastewater tool results in terms of net present worth of cost per cubic meter. And we can see alternative three has the highest net present worth cost, and alternative has the lowest net present worth cost. And for all three, capital cost was the most prominent, and replacement parts and operation and maintenance were the least prominent for all three alternatives. On this slide, we have the results in terms of carbon footprint per cubic meter, and we can see alternative three has the highest carbon footprint, and alternative two has the lowest carbon footprint. The biggest impact for all three of these were treatment, and the least impact was infrastructure. And on this side, we have the eutrophication potential per cubic meter, and alternative one has the largest due to discharge to reclaimed water, and alternative three has the lowest, but also discharge to reclaimed water.
So alternative 2 is going to be our best system to implement when we are looking at the environmental factors. We are choosing the environmental factors as the most important because it will simultaneously result in a better social and technical and economic outcomes in the future. Thank you.